Hey everybody, Mr. Covey here, and this is on page 12 of your note packet. And what I'm going over with you here is geometric series. Okay, so please pay attention to the vocab here. We kind of have two different things that's designating. It's designating that we're talking about something that's geometric, that follows a geometric pattern as opposed to a arithmetic pattern, and then it's a series as opposed to a sequence. So really quick, what's the difference between an arithmetic and a geometric sequence? Well, you should remember that arithmetic means adding. You know, the A and the A help me always remember that. And by adding, of course, I mean adding or subtracting. And if I want to get fancy, arithmetic sequences have a common difference. You are going up or down by the same amount between each successive term, whereas a geometric sequence is a multiplying pattern, or you can think about it as dividing pattern, same thing. You are multiplying to get from one term to the next term. There is not a common difference. They call it a common ratio. You are multiplying by the same thing over and over. Cool. So you can have geometric and arithmetic patterns, and then you can think about them as a sequence or as a series. A sequence is just a list. So you can think about them as a list, and I can ask you what's the 84th number in the list, or you can think about it as a series, or they can ask you to think about it as a series, and that's a list added together. Not what's the 84th term, but what's the sum of the first 84 terms. What's the first term plus the second term plus up to the 84th term. If you want to get fancy, the little tongue twister that I always have in my head is that a series is the sum of a sequence. It's when you take a sequence, it's when you take a list and you add up all the terms. The series is a sum of a sequence. Cool. Okay, so we've already talked about an arithmetic series. You have an adding pattern. How do you add up a bunch of terms? There's a formula. And similarly, there's a formula for a geometric series. Cool. Really quick, I won't make you go through this, but I hope you realize the necessity for a formula, because this just gets really annoying, especially as you have more and more terms. So I'll show you, let's pretend like we didn't know this formula for a second. And I said, I got a geometric series, a geometric sequence with the first term 11 and a common ratio 2. Oh, okay, so I can figure out the next term and the term after that by just multiplying by 2. That's easy. And you want me to find the sum of the first 6 terms? Oh, well, if it's only 6 terms, it's actually not too bad. I can kind of all right, I can do my math, hopefully. And then figure out the 6th one. What? Now I have to put my brain to work. 352. All right. And then I could say, oh, but you want me to find the sum of the first 6 terms, so I could add those 6 numbers together and figure it out. Obviously, that's not terribly hard to do, but it's only 6 terms. If I asked you the first 600 terms, it would take forever. There is a formula for the sum of a geometric series. For finding a geometric series, which is the sum of a geometric sequence. And you can kind of guess the components. So if I'm saying add up a bunch of numbers, well, first I have to tell you how many numbers I want you to add up. Okay, so n, is it going to be, again, the number of terms? So you got to tell the person how many terms you want to add up. Second, you have to tell them about the pattern. And if it's a geometric pattern, what you probably need to tell them is what's the first number, the first term. And then you also probably need to tell them the common ratio. In other words, how you get more terms. What do you multiply by to get the rest of the terms? That's your common ratio. If you know those things, if you know the number of terms you want to add up, you know the first term, and you know the common ratio, so you know how to get from one term to the next term, you can figure out the sum of a geometric series. Here's the formula. Please note that it has those components we just talked about. So you have to know the first term, you have to know the common ratio, and you have to know the number of terms you want to add up. It doesn't have the annoying thing that the arithmetic series formula has, where you have to know the last term. Remember, that was that annoying hard part about the arithmetic series formula? The geometric series one doesn't. It's actually really nice and easy to use. You might see it written different ways just because it's pretty easy to algebraically manipulate. So you might some people might have the A1 out there, and it might look more like that or something, but they're all algebraically equivalent. So you might have to see it written different ways. I write it the first way that I wrote it. Cool. There's not much to this. You have a formula, plug in the stuff, figure it out. So with the formula, I could figure out this sum real quick. All right, you want to know the sum of the first 6 terms? Well, first term's 11. Common ratio, 2. I want to add up the first 6 terms. Toss in your calculator. Get the answer. Cool. I should have brought my calculator with me. I'm coming unprepared to make videos. It's amateur hour, right? All right. But you get out whatever the answer is. Cool. Okay. Let's do this one together. Go. All right. If it just says find the sum of the first 8 terms in the series below. Okay, not too bad at all. Again, if it's only 8 terms, it's hardly even need the formula, but let's use the formula. Okay. First, it just says the sum of the series. You need to check now, moving forward, whether it's arithmetic or geometric or neither. If it's neither, then we don't have a formula for finding the sum. But if it's arithmetic or geometric, we do. Oh, you should be able to look at that real quick and say, oh, it's geometric. It's multiplying by 6. All right, I can find the sum of the first 8 terms. First term times 1 minus, what's the common ratio? 6 to the n. So 1 minus common ratio to the nth power. So to the 8th power divided by 1 minus the common ratio. Okay. Take a second, toss it in your calculator. I will too. I just came woefully underprepared. I should have been more prepared than this. I got 671,846. Cool. Negative. Yeah. Cool. That's what I was just going to say. So make sure you keep track of whether the answer should be positive or negative. Cool. So here I am. I feel like that answer is wrong. Let me double check something. Nope, we're good. Keep it in mind whether the answer should be positive or negative. Here, all the terms are negative, and they're going to keep being negative. And so these are all going to be negative. You're adding up a bunch of negative numbers. It makes sense that the sum is negative. Cool? Okay, moving forward. Next problem. They get increasingly hard, okay? It says, find the sum of the first n terms in the series below. That's kind of weird. What does that mean? Oh, it means they want me to find the sum of a certain number of terms, but they're not telling us the number of terms. What they are telling us about this pattern is that the first term is 2. If you haven't noticed, I'd always kind of write out the sequence. So I don't go right to the formula. First, I start thinking about the list they're talking about. All right, you're talking about a list of numbers with the first number 2. An nth number of 4,374. In other words, a last number of 4,374. Okay, that's the last number they want me to add up, but they don't tell me whether that's like the 19th number, the 7th number, or the 48th number in the list. It's kind of weird. And they give me the common ratio. Oh, well, that's good. So as soon as I see that R, I know it's geometric. I can start writing out this list. It's 2, 6, 18, 54. Okay, and they're telling me to add all those up and keep adding them up until I get to 4,374, wherever that is. I don't know if that's the 19th or the 75th number, whatever. Add all those up. That's what they're asking me to do. All right, cool. I'll grab my formula. Sum of the first, well, I don't know n. It's 1 minus the common ratio to the nth power divided by 1 minus the common ratio. Forgot the first term out there. First term times 1. Okay. The problem is, this is what I'm trying to figure out. I'm trying to figure out this guy, and I don't know the number of terms. Side project. I repeat, side project. So a lot of these problems, in order to use the formula, you're not going to have all of the inputs, so you're going to have a little side project where you need to figure out that input. This side project's not too bad. What's the side project? I need to figure out where this shows up in the list. Is it the 34th number, the 78th number, the 110th number, The 9th number, where is it in the list? That is a sequence question. It is literally just where does that show up in this list? I'm going to go over here. I'm going to do my side project, which is going to rely on my geometric sequence formula. Why? Because all I'm trying to do is figure out where that shows up in the list. All right, well, I'm just going to plug in what I know. I'm trying to figure out where that shows up. I know the first term's 2. I know the common ratio is 3. I'm trying to figure out n. I hope you look at this and go, oh, wait, I've kind of solved this problem before the other day in class, and this just looks straight up like last unit, right? That's just a straight exponential equation that I can solve. Cool. Let's solve it. Cool. Take a minute and solve it. You have 2 choices here. The nice part about this is, and I think I mentioned this to you, but if I didn't, all these equations are same base, oh yeah, kind of, right? Because you know it's 3 to some power, it's going to be a whole number. So you can totally use logs. You can solve this the way we've been solving it, which is to convert it to logs. That's totally cool. Or you can kind of just figure it out because you know the answer is going to be like a whole number and you can kind of guess where you think it's going to be, right? So you can say like, I don't know, maybe it's 3 to the 8th. No, that's too big. 3 to the 7th. There we go. It's 3 to the 7th. So then 7 equals n minus 1. Or you can use logs. Cool. So then what's n? N's 8. Oh, that's just the 8th number in the list. I feel like that's only the 8th number in the list. Don't forget these multiplying patterns get really big really fast. That's the whole idea with exponentials. That's the whole idea with geometrics is they get really big really fast. So that number, there's the 1st, 2nd, 3rd, 4th. There's only a few numbers in between. 5th, 6th, 7th, and then that one shows up. Cool. So then I jump back to my formula. I did the side project. Again, I'd like kind of keep this separate in your brain. There's the side project. I solved the side project to get n is 8. Jump over here, toss that in. And now I'm ready to roll. Cool. Again, take a minute to type this into your calculator to make sure that you're getting out the right number. You can put this in parentheses if you're having issues. Or you can also do some of the typing in like one step at a time. Cool. So you can do like 1 minus 3 to the 8th. Give me a second here. And then multiply that by 2. You know, you can do it like in steps if you want. Cool, and then I got like, or you can just type it all in at once, whatever you want. Okay, I got out 6,560. Again, and now I know I should get a positive number. Why? Because I'm adding up a bunch of positive numbers, so it kind of makes sense that they'd add up to that. Cool? Okay. I'm going to do one more problem with you. I'm going to do example 4. Cool? Okay. Ready? It says determine the number of terms. Okay, so find the n in a geometric series below. Okay, well, they tell me the first, the second, the third, and they tell me this. This is where you got to be on point about the notation. Pay attention right now. This is a common mistake. They are telling us that I don't know how many terms there are, but when I add them all up, I get negative 87,380. I'll repeat that. When I add them all up, I get negative 87,380. It's not saying negative 87,380 is one of the numbers in the list. It's not one of the numbers in the list, probably. It's what you get when you add up a certain number. So the question is, did I add up the first 9 numbers to get that, or the first 7 numbers, or the first 14 numbers? How many numbers in this list did I add up to get this? Oh, this is really important. I should have said this before. Whereas for the sequences stuff, you can kind of wing it. If you understand how sequences work, you don't really need to rely on those formulas that much. With the series, you kind of got to rely on the formulas. Okay, it's really hard to wing it, except for just doing it by brute force, but you can't like intuit the formulas as much. Which is why when I told you this formula, I did not say, that's the formula, of course. because for me, it doesn't really have a lot of, there's not a deeper math connection that I make when I see that formula. I'm not like, of course, that's how you find the sum of a geometric sequence. No, that's just the formula. You can algebraically derive it. I'm not going to do it for you. But you really do need to rely on that formula. So this is one of those times, you know me, I'm not a big formula guy, but where you need to rely on the formula. So I see this information and I grab my formula. I go, all right. Let's start plugging in. Well, they're telling me the sum. I know the first term. They told me it was geometric, or I can just look at it and figure out it's geometric. It's times 4. So I know the common ratio is 4. They're asking me the n. No, I'm actually in good shape here. Okay? Why? Because this is just an equation I can actually solve. Be a little careful about how you solve this. This is an equation I can solve. I'm just solving for one variable. N's the only variable I'm solving for it. Keep in mind n's an exponent. So I'm going to probably have to use logarithms to solve this equation. Okay? Here's how you solve this. Okay? I'm going to grab out my calculator. Okay. First, I'm going to do the 1 minus 4 in the bottom. So I'm going to get negative 87,380 equals negative 4 times 1 minus 4 to the n divided by negative 3. I'm going to multiply the negative 3 over. You don't have to do it this way. I'm just going to show you kind of like the way that my head goes when I see this algebraic equation. 262,140 equals negative 4 times 1 minus 4 to the n. You might see this and be tempted to distribute that negative 4. No, because of that exponent on the 4 to the n, you cannot do that. Do not do that. You cannot do that. Instead, sorry, I just want to see something. Instead, how do you get rid of that negative 4? You divide both sides by negative 4. Okay, stick with me. You get negative 65,535 equals 1 minus 4 to the n. Be careful here. You want to get rid of that 1 minus 1. You get negative 65,536 equals the opposite of 4 to the n. Notice how I'm saying that, not negative 4 to the n, the opposite of 4 to the n. Make them both positive. Divide both sides by negative 1. And here is the question. Again, you can use logs to figure this out, or you can just rely on the fact that you know it's got to be some whole number power, and you can kind of just guess. I don't know, is it 4 to the 11th? No, that's too big. Is it 4 to the 9th? Yep. No. 4 to the 8th? Yep. It's 4 to the 8th. N is 8. Or you guys know how to solve this now. I'm like confident that you guys are good at this now. You can use logs. It's log base 4 of 65,536, and it will spit out 8. That's the answer. Cool. I added up 8 terms. The first 8 terms in this list, you get negative 87,000. Cool. All right, that concludes this video. We're going to talk lots more about this, but hopefully that gives you a little bit of an idea.